Welcome to this explainer. I am so pumped to jump right in today. We are going to be looking at a huge, honestly kind of hidden bottleneck in the global green transition. We hear about the massive shift to sustainable energy literally every single day, but there's this invisible, absolutely crucial piece of tech making the whole thing tick, and its supply chain is incredibly fragile.
When we picture a green future, right, we usually think of sleek electric cars cruising down the highway or those massive wind turbines spinning off the coast. But hiding inside those amazing end products of the green transition is a highly specialized piece of hardware that literally makes our sustainable future spin. And this number really tells the whole story. 95%. 95% of all electric vehicles rely on rare earth magnet motors. There's just no way around it. Without these highly specific magnets, we simply can't get the max energy efficiency and those long driving ranges that actually make EVs a viable alternative to traditional gas cars.
So what exactly is this thing? Well, it's the N-FeB permanent magnet. That stands for neodymium, iron, and boron. It's an advanced material that's basically the nucleus of clean tech. You absolutely have to have it to build these highly efficient electric motors.
Okay, so let's quickly map out how we're going to tackle this giant geopolitical puzzle today. We'll start with the green transition's hidden engine, then look at the Chinese monopoly problem, move on to an unlevel playing field, explore the true cost of magnets, and wrap up with Europe's mine-to-magnet master plan.
All right, part one. The green transition's hidden engine. Let's see how these materials actually work in practice. This gives us a perfect look at the mechanics behind the magic. See those gray blocks mounted right inside the rotor? Those are our rare earth permanent magnets. What happens is, their magnetic field interacts with the electric current running through those copper coils, and that physically forces the motor to spin. It's an absolute masterpiece of engineering that turns electrical energy into physical motion with just unmatched efficiency.
But here comes the bottleneck. Global demand for these EV magnets is projected to just explode. We're talking a leap from 5,000 tons back in 2019 to potentially 70,000 tons by 2030. That is a mind-boggling scale of demand, and it's all being driven by our massive global shift towards electric mobility.
Which leads us straight into part two, the Chinese monopoly problem.
So we kind of have to pivot from the cool technology side over to a rather harsh geopolitical reality. There is a massive single point of failure in the global supply chain right now. China completely dominates, controlling a whopping 93% of global permanent magnet production. Japan sits at 6%, and the entire European Union, less than 1%.
Let's break down just how exposed Europe is here, especially considering they want to be the undisputed global leader of the green transition. The vulnerabilities are pretty extreme. There's a 98% import reliance on China for these specific magnets. The recycling rate for these materials in Europe is less than 1%, and right now, there is zero active rare earth mining happening anywhere inside the EU.
To really put the leverage into perspective, think of it as a classic David and Goliath scenario. The global rare earth magnet market is actually pretty small. It's valued at around 6.5 billion euros. But look at what's riding on it. A staggering 400 billion euro European mobility market that employs 6 million people. So this tiny, highly concentrated 6.5 billion euro market effectively acts as the gatekeeper for the entire massive European automotive sector.
Let's jump to Section 3, an unlevel playing field, to understand why European producers are having such a hard time competing.
You might be wondering, well, why can't European manufacturers just step up? The truth is, the trade dynamics are totally skewed. A Chinese magnet exporter gets a 13% VAT refund from their government when they ship magnets out. But a European producer, they have to pay full tax just to import the raw materials. It creates this massive cost disadvantage before a single magnet is even manufactured.
And let's look at how this builds into an almost insurmountable advantage. $226 million. That was the scale of the VAT refund handed out by the Chinese government in 2019 alone. That's not just a minor competitive edge, it's a huge state subsidy designed to solidify their market dominance and make it incredibly hard for anyone else to break in.
Moving on to part 4, the true cost of magnets. Because there is a lot more at stake here than just the financial price tag. There's a major environmental nuance we need to talk about. Not all magnets are created equal when it comes to the planet. The CO2 footprint actually varies wildly. Mining and processing the raw materials from scratch, primary raw materials, has a very high carbon footprint. But if we shift towards secondary raw materials through recycling, that footprint drops dramatically.
So controlling the domestic supply chain isn't just a smart economic move, it's a huge part of guaranteeing actual sustainability.
Let's put a face to all this data. Listen to what Giles Dixon, the CEO of Win Europe, has to say. He points out, a European rare earth and permanent magnet supply chain would bring jobs and growth. We are working to improve our material efficiency rates and actively exploring substitution options. Major industries are literally desperate for sustainable, diversified options because they know the current setup is way too risky.
And if you want to know why the wind industry in particular is so deeply invested in this, well, take a look at these offshore turbines. Just one of these massive structures needs several tons of rare earth permanent magnets just to operate efficiently. The entire future of European wind power is completely tied to these materials.
So, how do we actually fix this? That brings us to our final section, Europe's Mine-to-Magnet Master Plan.
The European Raw Materials Alliance has put together a serious plan, identifying 1.7 billion euros in investments to claw back some industrial independence. This money spans 14 different projects across Europe, all designed to basically jumpstart this entire domestic industry from the ground up.
Let's walk through the concrete steps for building that supply chain from scratch. First is exploration and urban mining. I love that term, urban mining. It basically means intensively recycling the electronics and motors we already have. Second is the separation and refining of those materials, and third is actually manufacturing the magnets right at home.
Now, what's really smart about this goal is how realistic it is. They're aiming to secure 20% of Europe's rare earth magnet needs domestically by 2030. They aren't trying for 100% independence right out of the gate. They just want to build a solid 20% buffer. And that buffer is absolutely critical for protecting downstream industries if there's ever a major supply shock.
But for these huge investments to actually survive against an established monopoly, we need some tactical changes in the market. Original equipment manufacturers have to commit to European sourcing. We need a truly level playing field. We have to legally mandate the recycling of end-of-life products. And finally, we need to unlock match funding to help back private investments across the whole value chain.
Which brings us to the final, really provocative question of this explainer. Will Europe actually secure its own green future, or is it just trading a historical reliance on foreign oil for a brand new reliance on foreign magnets? It's an absolutely massive geopolitical puzzle, and the clock on the green transition is definitely ticking. I hope this explainer helps shed some light on the invisible engine driving our future. Thanks for tuning in, and keep questioning the world around you.